For thousands of years, the Great Pyramid of Giza has been the ultimate symbol of ancient ambition, a man-made mountain of stone standing taller than a 48-story building. We're talking about more than 2 million blocks, each weighing about 2.5 tons, all stacked with bewildering precision. The sheer scale of it is so immense that it almost feels impossible. And for centuries that feeling has fueled some pretty wild speculation, from lost super technologies and legions of slaves to, you guessed it, a little help from another world. But the real story is far more clever, and it was hiding in plain sight, just waiting for us in an old forgotten quarry. So forget the alien architects. This is a story about human brilliance. In 2018, a discovery was made, not at Giza, but miles away, at a site called Hatnub. Archaeologists there unearthed a 4,500-year-old ramp that completely rewrites our understanding of how the pyramid builders conquered stone. And this isn't just a theory, it's a physical blueprint, a working device that finally solves one of the greatest engineering puzzles of all time. So, just how big of a problem were the Egyptians trying to solve? The Great Pyramid, built for Pharaoh Khufu around 2560 before Common Era, is a logistical masterpiece. It has more stone in it than all of England's cathedrals and churches put together. Most of the limestone blocks were quarried right there on the Giza plateau. But the gleaming white casing stones came from Tura, across the river, and the massive granite beams for the inner chambers, some weighing up to 80 tons, were dragged all the way from Aswan, over 500 miles away. Recent finds have shown us that a now-vanished arm of the Nile River flowed right up to the construction site, and with a smart system of canals and ports that solved the long-distance travel. But that only got the blocks to the base of the pyramid. It didn't solve the vertical problem, and that's always been the real head-scratcher. How did they lift millions of multi-ton blocks, day after day for 2 decades, to a height of nearly 500 feet? The go-to theory has always been ramps. The problem? The physics just didn't seem to work. A standard ramp can't be much steeper than a 10% grade if you want to drag something heavy up it. To reach the top of the Great Pyramid, a single ramp at that angle would have to be over a mile long, a project even bigger than the pyramid itself, with zero evidence it ever existed. Other ideas, like a spiral ramp wrapped around the outside, would have made it nearly impossible to keep the pyramid's perfect geometric shape. The ramp mystery just couldn't be solved, and that's where the story gets good. In Egypt's eastern desert, there's an ancient alabaster quarry called Hatnub, which was in use at the exact same time the pyramids were being built. In 2018, a team from the French Institute for Oriental Archaeology and the University of Liverpool was taking a fresh look at the site. And there, carved right into the bedrock, they found something that had been missed for decades, the remains of an incredibly strange and wonderfully preserved ramp. This was no ordinary ramp. It was brutally steep, with a slope of about 20%, double the angle experts thought was possible for moving heavy blocks. On either side of the ramp were staircases, and dug into those stairs was a series of large, deep post holes. Inscriptions found nearby helped date the ramp system right to the era of the Great Pyramid builders, around the time of Pharaoh Khufu. What the archaeologists were looking at was a 4,500-year-old machine designed for heavy lifting on insane inclines. The team, led by Yanis Gordon and Roland Enmarsh, knew they had stumbled onto a lost piece of Egyptian tech. This wasn't a model. It was hard evidence. The real mystery wasn't how they built the pyramids without ramps, but what kind of genius ramps they were actually using. And the secret was in those holes. So, how did this brilliant device work? It's all about clever physics. A huge stone block was placed on a wooden sledge on the central ramp. Ropes were tied to the sledge, but instead of just having guys hauling from the top, the ropes were looped around big wooden posts, anchored in the holes along the stairs. This created a powerful force multiplier system. One team on the stairs above the block would pull it up. At the same time, another team on the stairs below the block would pull down on their end of the rope. The post acted like a pulley, turning their downward pull into upward force on the sledge. By having teams pulling from both directions, they could move incredibly heavy loads up slopes that should have been impossible. The Hatnub ramp proves that when the Great Pyramid was being built, the Egyptians already had the know-how to move massive blocks up very steep slopes. It's a direct solution for how they got blocks out of deep quarries, and more importantly, it's a blueprint for how they could have tackled the pyramid itself. Instead of one giant mile-long ramp, they likely used a series of shorter, steeper ramps, maybe in a switchback pattern up the sides of the pyramid. This would have been way more efficient, used fewer materials, and let multiple teams work on different levels at once. The Hatnub ramp isn't just one piece of the puzzle. It's the key that helps the rest of the evidence click into place. It just goes to show you, sometimes the biggest mysteries aren't solved by looking to the stars, but by digging a little deeper into the sand. If you find the process of uncovering these lost technologies as fascinating as we do, take a moment to subscribe. We're dedicated to bringing you the real, evidence-based discoveries that show off the true genius of the ancient world. The Hatnub ramp is a game-changer, but it was likely just one tool in a whole toolkit of brilliant methods. For the very top of the pyramid, other ideas are getting serious attention. French architect Jean-Pierre Houdin has spent years arguing that an external ramp was used for the lower third, while the rest was built using a corkscrew-shaped internal ramp. And modern scans using muon tomography have actually found mysterious voids inside the pyramid, right where Houdin's theory predicted a ramp would be. Even more recently, a 2024 study suggested a wild idea for Egypt's very first pyramid, the Step Pyramid of Giza. Researchers think the builders might have used a hydraulic lift, using water from a nearby dam to raise a platform carrying stones up through a central shaft. If that's true, it shows they were mastering complex engineering even earlier than we thought. So what we're really looking at isn't one single secret, but a civilization of incredible problem solvers who adapted their methods to every challenge. They used canals for transport. They used force-multiplying ramps for steep quarries and the pyramid's lower levels. And they may have switched to internal ramps or other complex machines to reach those final dizzying heights. For centuries, the Great Pyramid made us wonder if its construction was just too advanced for ancient people. The discovery at Hatnub answers that question with the force of stone-on-stone evidence. It proves the pyramid builders weren't just organized, they were innovators. They were masters of physics and logistics who came up with brilliantly simple solutions to monumental problems. The Great Pyramid isn't a monument to some forgotten super science or alien intervention. It's a monument to human ingenuity, a 4,500-year-old story of what we can achieve with cleverness, cooperation, and the will to build something that lasts forever. The secrets of the pyramid aren't lost. They're just waiting in the sand for us to find them.